Today we are going to discuss about exception concept in Java. An exception is an unexpected event that occurs during the execution of a program and disrupting the normal flow, which means a problem occurs or an exception occurs during execution of the program. Okay, exceptions occurs due to logical errors, invalid inputs, and hardware failures, so on. And also, Java provides a robust exception handling mechanism to handle such errors, and also it prevents the program crashes. And what happens when an exception occurs in our program? When an exception occurs, the program stops suddenly, then JVM creates an exception of the respective type, which means whenever an exception occurs, the execution of the program will stop suddenly. JVM creates an object inside the heap area with respect to exception type. Then JVM searches for an exception handling mechanism. Later, JVM searches for an exception handling mechanism. If exception handling mechanism is present, it handles the exception and continue the execution of the program. And if no handling mechanism is present, the default exception handler terminates the program. Which means if the exception handling mechanism is not present, then defaultly exception handler will handle the exception and execution of the program will stop. Yeah, exception handling mechanism in Java. Exception handling mechanism, which means it is used to handle the exception. And we can handle these exceptions using try, catch, and finally block. Okay, try. It defines a block of code, might throw an exception. Yes, inside the try block, we are writing the statements which are responsible for exception. Inside the try block, we are writing the risky code. Okay, when an exception occurs, JVM create an object inside heap area with respect to the exception type. Since JVM create an exception object, every object is having some address or reference, right? So try block will throw the reference of a particular exception type to the catch block. Okay. Here try block will throw the reference to the catch block. Catch block is used to handle that exception if it occurs. After catching the reference, the statements which is present inside the catch block will get executed and the execution of the program will continue. Finally block, a block that always executes regardless of whether an exception occurred or not. Which means finally block is used to execute important instructions and also it will execute if exception is occurred, if exception is not occurred, if exception is handled and also if exception is not handled. Okay. And how to handle the exception in Java. As we already discussed with the help of try, catch and finally blocks, we can handle exceptions in Java. Okay. Try block. A try block contains code that may generate an exception and the catch block catches and handle that exception. Here you can see. So it throws an exception object. In try block, here we are write exception causing statements and in catch block, here we are write exception handling statements. In try block, exception objects get created here and here used to handle the exceptions. And one more rule is catch block will execute only when try block throws a reference to the catch block. And we can't declare a catch block without try block. And also we can declare a catch once after declaring the try block. Okay. And next one is finally. Finally block always executes even if an exception occurs. And it is used to clean up the operations like closing files, database connections and so on. Here you can see the example. Before going to this example, you need to remember 2 points. First one try block can be followed by multiple catch blocks. Okay. Can be followed by multiple catch blocks. And next point is we can declare a catch block once after declaring a try block. Catch block once after declaring a try block. Okay. You need to remember these points. Okay. Here, what we have seen now is an arithmetic exception is 10 by 0. And also there are few like exceptions, array index out of 1. And there are different types of exceptions. So for each exception, you can write separate catch block. Okay. Example, here I have written exception. Here exception is a generic one. So for any error, it will support. Inside the try block, here I am writing the exception causing statement. In catch block, here if you are not sure about what kind of exception it is, then you could simply write an exception. It is a parent class. It can accept all kind of exception. Here E is just a variable assigning object to this class. And just give us there is no specific thing. Even you can go any of your choice. Here I give ET. It will not get any error. Whatever you want to give here, you can. Okay. And next one is finally block. So finally block is used to execute important instructions. Even exception is occurred, it will execute the statement. If exception is not occurred, even though it is execute the statement. Let's run the code. Let's see what happens. Here you can see I catch exception and finally block also it got executed. Okay. Then if you want to catch a specific exception, then you have for this 10 by 0, which is infinity. This exception called arithmetic exception, I guess. So let's create one more catch block. Here I'm giving arithmetic exception. Okay. Here I'm giving arithmetic exception and I catch arithmetic exception. Let's run the code. So here I'm printing the message as I catch arithmetic exception. So here try block is checking for its related error in catch block. It feels that arithmetic exception is the right one. So it went to this loop and printed. So this time arithmetic exception is printed because the error is related to this. Okay, let's run the code. Here you can see I catch arithmetic exception and finally block also printed. Yeah, as I said, we can use multiple catch blocks. So I can create one more index out of bound exception. So here I comment this one, and this time I would like to change the exception. So I will declare an array. So int ARR equals to new int of, I'm giving the size as 5. Okay. Inside the catch block, I would say to print ARR 7. Okay. So here I will declare an array, and I would say to print here array of 7. Okay. Here I will change this message index out of bounds exception. Okay. In this code, you will get an error index out of bound exception. Okay. Here you can see catch index out of bound exception. Why? Because here I define the size as 5, but I'm trying to print the index 7, which is index out of bound exception. Okay. So try is checking for this related error catch block, and it feels that is index out of bound exception is the right one. So it feels this one is right one, so that it went into this loop and printed the statement. So this time arithmetic exception is not printed because the error is not related to that. Error is related to index out of bound exception. So it prints the statement. Okay. And types of exceptions in Java. There are 3 types of exceptions: checked exceptions, unchecked, and error. Here, checked exception. It is also known as compile time exception. These exceptions must be handled in the program either using try catch or throws, which means compiler aware about this exception is known as checked exceptions. In case of checked exception, compiler will force the programmer to handle the exception. If the programmer fails to handle the exception, compiler will throw an error. Here you can see some of the examples of these exceptions. IO exception will be occurred file not found and file reading error. SQL exception, and last one is file not found exception. And next one is unchecked exception. Unchecked exception is also known as runtime exception. These exceptions occurs during the execution and do not require explicit handling, which means compiler unaware about this exception is known as unchecked exception. In case of unchecked exception, compiler will not force the programmer to handle the exception. These exceptions occurs during the runtime and do not require explicit handling. Here some of the examples: arithmetic exception, null pointer exception, and array index out of bound exception, number format exceptions. Okay. And few more are there: string index out of bound exception, and so on. And last one is errors. Errors are not exceptions, they indicate system level failures. Here you can see examples of errors: stack overflow exception, out of memory exception, and so on. Declaring an exception in Java. In Java, you can declare an exception using throws keyword in the method signature. So, throws is a keyword. It is used to declare the method. It declares that the method may throw an exception, which means throws is a keyword. It is used to declare or ignore the exception. And here you can see the syntax of throws. Here we are declaring an exception using throws keyword in the method signature. Here we are raising an exception. How you can raise an exception? You can raise an exception using throw keyword. Throw is used inside a method to manually throw an exception. Yeah, throw keyword is used inside a method. Throws is used in the method signature. This is the main difference. Okay. And it must be followed by an exception object. And this is the syntax for throw keyword. Now we can write an example for throw and throws keyword. Okay. See, this is the example for throws and throw keyword. Here I am declaring a method named as validate age and passing a parameter int age. Here I am giving one condition: if age is less than 18. So this condition checks if age is less than 18. And I am throwing an exception manually using throw keyword. Throw new illegal argument exception. Here I am printing one message: age must be 18 or above. And this line will execute only if age is 18 or above. And inside the main block, here I am writing try block and catch block. Inside the try block, here I am calling a method with an invalid age. Here I am giving the age 16. So since 16 is less than 18, it will throw an exception. Inside the catch block, this block will catch the exception thrown by the validate age. So it prints the exception message. Okay. And this line will execute after handling the exception. Let's run this code. And one more thing, there are two important methods. Get message. It is used to get small information. It is used to get small information about exception. Okay. Next one is print stack trace. Print stack trace. It is used to get detailed information about exception. Information about exception. Okay. Let's run this code. Here you can see exception caught age must be 18 or above. And also it prints this statement. Okay. If I give age value as 19, it will print this statement. Why? Because there is no exception occur here. Let's run this code. Here you can see this print statement will be executed. Why? Because this line will be executed if age is 18 or above. Here I am giving the age value as 19. So it will print this statement. That's it. Today we are going to discuss about collection framework. Before the introduction of collection framework, let us discuss about disadvantages of arrays. Fixed size. Arrays have a fixed size and can't be resized automatically, which means you can't change the size of an array once it is created. Okay. Manual operations. Lack of built-in methods for searching, sorting and inserting. It means you must write the code for searching, sorting and inserting. Slow insertions or deletions. Shifting elements makes modification inefficient. It means adding or removing the elements takes extra time due to the shifting. Homogeneous data. It supports only one data type per array, which means an array can only store one type of data. No direct support for data structure. It requires extra coding for stacks, queues, etc. Else, it means extra support is needed to implement stack, queue, etc. And memory wastage. Oversized arrays waste memory. Resizing is challenging. It means unused space is wasted and resizing is difficult. Okay. So to avoid the disadvantages of an arrays, we are using collection framework. Framework is a set of classes and interfaces in Java. Collection framework is a set of classes and interfaces, and also it is used to store and manage group of objects efficiently. Here you can see advantages of collection framework. Here you can compare the advantages of collection framework and disadvantages of arrays. Here fixed size. Array is fixed size and collection framework is dynamic size. Collections can grow automatically as needed. And here manual operations, lack of built-in methods for searching, sorting and inserting. Here built-in methods, it provides some methods to add, remove or sort and search elements easily. And it is better performance which uses optimized data structure for fast operations. And it is flexible. It supports various types of collections like list, set, queue and map. And it reduces the code complexity, which means developers don't need to implement common data structure manually. Java collections framework. Here you can see collection framework is a set of classes and interfaces in Java. Here collection is an interface, list is an interface, set is an interface, and map is an interface. So here list is the sub interface of collection interface and set is the sub interface of collection interface. Here you can see ArrayList. ArrayList is a class. Here these are all our classes. So it is the implementation class of list interface, and LinkedList is also the implementation class of list interface. HashSet is also the implementation class of set interface, and TreeSet is also the implementation class of set interface. Map is an interface. Here HashMap is an implementation class for map interface, and TreeMap is also an implementation class of map interface. Here list allows duplicate values. Here set will not allow duplicate value. Map is a collection of key and value pair, and key should be always unique and values can be duplicate or repeated. And here both key and values is considered as an object. Okay. Today we are going to discuss about list interface. So list interface is the sub interface of collection interface. Here collection interface is the root interface of all the collections, and that defines several methods for handling group of objects such as adding, removing and checking the elements. Coming to list interface is the sub interface of collection interface, and it is used when elements must be stored in order and duplicates are allowed, which means list maintains insertion order and also it allows duplicates, and also list provides index to the elements. Now let's do an example for list interface. Okay. Now I'm creating an object of list using ArrayList. Here I'm choose java.util package. So here I'm importing java.util package. Here I'm pass a type as string, and this is list, ArrayList. Okay. Now I'm going to add elements to the list. So list dot add. I'm add apple to the list. Here I'm going to add apple to the list, and one more element I need to add. Here I'm going to add banana. Now I'm printing the list. List. Let's run the code. Here you can see apple and banana added to the list. Okay. Now we are going to check list allows duplicate values, right? Now few more elements I'm going to add to the list. Here I'm going to add grapes to the list. And again same element apple is added to the list. Let's see it will work or not. So apple. Now I'm printing this list again. Let's run this code. Here you can see apple, apple. Two times it will display. Why? Because we are adding apple element twice. So it returns 2 times. Now I'm going to access this element with the help of get method. Here list dot get of. Here I'm specifying the index. Based on the index value, it will return the element. So banana index value is 1. So here I'm specifying the index as 1. Now you can run this code. Here you can see we can access the banana element here. So list allows duplicate values. Here you can see apple, apple 2 times it will display. And also list maintains insertion order. And also we can access the elements with the help of get method. We are going to discuss about ArrayList. ArrayList is the class which implements the list interface. So ArrayList, it implements a dynamic array, which means ArrayList automatically resizes when elements are added or removed, and it is fast for searching but slow for insertion and deletion. As ArrayList is fast for searching, but it is slow for inserting and deleting the elements to the list. Now we are going to see an example for ArrayList. Now here I am creating an object for ArrayList. Here I am passing a type as integer. A1 equals to new ArrayList. This is ArrayList constructor. Now here I am going to add elements to the ArrayList. A1 dot add. So here I am going to add integer values. 60 dot add 80. A1 dot add 90. So here I am adding elements to the array list. Now here I am printing the complete array list. Out dot println. Sorry. So here I am printing the array list. Now let's run this program. Here you can see we are adding elements 60, 80 and 90. A1 dot add. Here I am add 70. So here you can see the initial capacity is 2, but here this exceeds the initial capacity. But ArrayList automatically resizes when we are adding elements or removing the elements. Let's see how it works. Let's run this code. See, here it exceeds the initial capacity, but it returns the output. Why? Because it automatically resizes the capacity when we are adding or removing the elements. Okay. Now one more point we are going to discuss here. Let's close this console and let's comment these lines. Okay. ArrayList is a combination of heterogeneous and homogeneous collection of elements. Let's see how it works. So again I'm creating an object of ArrayList. So here I'm going to add one integer value, a1 dot add. Here I'm adding 60 value. Now I'm going to add a character to the ArrayList. So a1 dot add. In single quotes I'm going to add a character a. Now I'm going to add boolean value to the ArrayList. A1 dot add. I'm going to add true value. Now I'm going to add string Java to the ArrayList. A1 dot add. Let's print this list. Now I'm going to printing the ArrayList. Let's run this program. Here you can see it's add integer value, character, boolean, and so ArrayList is a combination of both homogeneous and heterogeneous elements. Okay. Now we are going to discuss few more methods in the array list. Let's comment these lines. Now I'm creating an object for array list of fruits. So I'm going to add elements to the list. So fruits dot add. I'm going to add banana to the list. And one more element I'm going to add. Again one more element I'm add. Now I'm changing the element. Apple. Now here I'm going to add grapes. Here I'm going to add cherry to the list. So now I'm printing the list out. Println. Sorry, here I'm printing the fruits. Here you can see. Let's run this program. Here you can see apple, banana, grapes, orange are added to the list. Now I'm going to remove banana from the list. Remove method is used to remove the object from the collection based on the given object. Okay. So here I'm going to remove banana from the list. Fruits dot. I'm using remove method. So here I'm giving the name as banana. So it removes banana from the list. Let's run this program. Sorry, I'm not giving the printing statement here. Let's print the fruits again. Here you can see the output. Here you can see in the previous list it had banana is there. Now I'm using remove method to remove banana from the list. So here this list you can see banana is not there. Okay, it removes banana. So one more method we will discuss. And next method is contains method. It is used to check whether the object is present in the collection or not. If it is present, it returns true, else false. So here you can see. Let's print this one. Here you can see fruits dot contains of here I'm giving the name as apple. If apple is present in our list, it returns true, otherwise it returns false. So let's run this code. See here, it returns true. Why? Because apple is there. In case here I am giving the name as banana. Let's run this program. Here you can see it returns false. Why? Because here I am removing the banana from the list. So banana is not there in our list, so it returns false. If element is present, it returns true. Otherwise, it returns false. Okay. And next method is index of. This method is used to check whether the given object is present. If it is present, it returns the index of a particular object, else it returns -1. Let's print it. Let's see. Copy this one. Here I'm using index of. Index of. Here I'm giving the name as orange. Now let's run this code. Here you can see orange is there at the specified index 2, so it returns the index value as 2. Here I'm giving the name as banana. Banana is not there in our list, so it returns. So it returns -1. Let's see. Let's execute the program. Here you can see banana is not there in our list, so it returns -1. So one more method we will discuss. This method is clear. This method is used to clear the current collection. This is our current collection, right? Apple, grapes, and orange. So if I want to clear the entire collection, I use clear method. So fruits dot clear. So I'm going to print this list. So I'm going to print the empty list. It removes all the elements. Let's run this code. So here you can see it prints the empty list. Okay. These are all few methods in array list. Now we are going to discuss about LinkedList. LinkedList is also a class, so it is also implementation class for list interface, and implements a doubly linked list, which means each node points to both its previous and next node, and it is fast for insertion and deletion, but slow for searching. Yes, it is fast for adding or removing the elements, but it is slow for searching the elements. Now we are going to see an example for LinkedList. Okay. Now I'm going to create new class. Class name as LinkedList example. Okay. Now here I'm quickly creating a method. Now here I'm creating an object for LinkedList. You can import java.util package equals to new LinkedList. Now here I'm going to add elements to the list. L dot add. Here I'm going to add string. L dot. Here I'm going to add 80 to the list. Again one more element here I'm going to add 90 to the list. So here I'm printing the entire list. Let's run this code. Let's change the file as current file. Or let's run this code. Here you can see 60, 80, 90. It returns the output here. Now I'm going to print the list using iterator concept. Before that, what is iterator you need to know. Iterator. So iterator is an interface. It consists of mainly two methods. One is HashNest. Sorry. And next method is nest. Here, HashNest method is used to check whether the collection contains nest element or not. If nest element is present, it returns true. Else it returns false. And next one is nest method. Whenever we are going to use nest method, first the controller will transfer to the element and it returns the current element. Okay. Now, getting an iterator for the linked list. Iterator. Here I'm going to pass a type as string. So I equals to fruits dot iterator. Now, here I'm creating an iterator to transfer the list. I'm iterating through the linked list using the iterator. So now I'm using while method. So I dot HashNest. Yeah, we will already discuss it here. HashNest is used to check whether the collection contains nest element or not. If it is present, element is present, it returns true. Otherwise, it returns false. Okay. So this line, I'm checking if an element or not. Now string dot. Sorry. Now string dot. Here linked list reference is L. Here I'm giving true. That's why it will get error. So I'm giving the reference L. So strings L equals to I dot nest. Here I'm going to print L. So let's execute this code. See here there is an error in this line. Here you can see variable L is already defined in the scope. Here we have defined variable L. So we need to change this name. So let I'm giving the integer values. Here I'm passing the type as string. Sorry, let's change the type as integer. Here also I'm going to change the type as integer. So this method retrieves the element and stores it to the empty variable. So this printing statement prints all the elements one by one. So let's run this code. Here you can see 60, 80 and 90. All the elements can be printed one by one. Now we are going to discuss about differences between ArrayList and LinkedList. ArrayList internally uses a dynamic array to store the elements. Coming to LinkedList, it uses double linked list to store the elements. And manipulation with ArrayList is slow because it internally uses an array. If any element is removed from the array, all the bits are shifted in memory. Here manipulation with linked list is faster than ArrayList because it uses a double linked list. So no bit shifting is required in memory. Here ArrayList consumes less memory than linked list. Here linked list consumes more memory than ArrayList. Here ArrayList class can act as a list only because it implements list only. Here LinkedList class can act as a list as well as queue because it implements list and Deque interfaces. And ArrayList is better for storing and accessing the data. Here LinkedList is best for manipulating the data. Now we are going to discuss about vector class. So it is the implementation class for list interface. It is similar to ArrayList but thread safe. Yeah, vector class is similar to ArrayList but it is thread safe. It is also allows duplicate values. It is also provides indexing and also it maintains insertion order. Now let us see an example for vector class. Again I'm going to create one more new class. Here I'm giving a name as vector example. So now I'm quickly creating a main method. Now I'm creating an object for vector class. I'm importing java.util.vector. So here I'm passing the type as string. V equals to new. Now adding elements to it. V dot add. Here I'm going to add Raju. Again I'm going to add one more element to the list. Adding Rani to the list. Sorry, I'm giving capital V. Now again I want to add one more element to the list. Here I'm adding Rosie to the list. So printing the vector. Here I'm printing V. So let's run this code. Sorry, let's change the file as current file. Now let's run this code. Here you can see Raju, Rani, Rosie. It returns the output here. This is the concept for list interface. In next section we are going to discuss about set interface. Thank you. Today we are going to discuss about set interface. Set interface is the sub interface of collection interface. Here you can see it is used when you need a collection of unique elements, which means a collection that stores only unique elements it will not allow duplicate values, and it is used for where uniqueness is required, like storing user IDs or product codes, so on. Now coming to HashSet. HashSet stores unordered unique elements. It means elements are not stored in order, but all are unique elements. And fastest among all set implementation. It means HashSet performs add, remove, and search operations quickly using hashing. Okay. And also, HashSet is the implementation class for set interface, so it is also will not allow duplicates, and HashSet will not provide indexing. And in HashSet, elements will be stored based on the hash code of an object. And also here, elements are stored in random order. Let's see an example. Again, I'm creating one new class. Class name is set example. Now I quickly create a main method. So here I'm creating an object for set. I'm importing java.util.set. So here I'm passing a type as integer. Num equals to new. So here I'm adding elements to the set. Num dot add 16, and again I'm adding 70 element to the set, and again I'm adding 60 element to the set, and again I'm adding 80 element to the set. So here you can see I'm adding 60 elements to the set 2 times, but set will not allow duplicates. Let's see how it prints. So here I'm printing the set. Now let's run this code. Here you can see 80, 70, 60. Here I am giving the 60 value 2 times, but here it displays only 1 time because set will not allow duplicate values. So set ignores the duplicate values. Here you can see I am giving an order 60, 70, 60, 80. Here you can see the order is 80, 70 and 60. Set. So in set elements are not stored in order. And you can see it ignores the duplicate values. It will give the unique values to the output. Now I'm creating an object for HashSet. So here I'm importing java.util.hashSet. So here I'm passing a type as string. Fruits equals to new HashSet. Here I'm adding elements to the set. So fruits dot add. Here I'm adding apple to the set. I'm adding one more element to the set. Here I'm adding banana to the set. And I'm adding one more element to the set. Grapes. And again I'm adding same element to the set. Apple. So here you can see apple I'm adding 2 times. So it is duplicate element. It ignores this element. Okay. Now again I'm going to add one more element to the set. Fruits dot add. Here I'm going to add orange to the set. Okay. Now I'm going to the print complete set. So here I'm giving fruits. Let's run this code. Let's see the output. Here you can see apple, grapes, orange and banana. Here you can see HashSet. It is the implementation class of set interface. It is present inside java.util package, and HashSet will not allow duplicates. That's why here we are giving apple as 2 times, but in the console here you can see it will return only 1 time. So HashSet will not allow duplicates, and HashSet will not provide indexing as well. Here we are inserting elements apple, banana, grapes, apple, orange. Here you can see apple, grapes, orange and banana. Based on this you can observe here elements are not stored in order, because in HashSet elements will be stored based on the hash code of an object. Okay. Few methods are discussed in list interface, right? Now one more method we are going to discuss here. Size method. It displays the number of elements in the HashSet. So here I am going to print this set again with adding a size method. So it displays the number of elements in the HashSet. So this method is used to display the number of elements in the HashSet. Let's run this code. Here you can see it displays number of elements in the HashSet. There are 4 elements are there, so it returns 4. Now we are going to iterating the HashSet using for each loop. So here I am writing one printing statement here, iterating through the set. Okay. So for each loop, right? For string, here I'm giving string. Why? Because here we are passing a type as string, right? So string fruit colon fruits. Sorry, fruits. Okay. Here you can see this fruits. Here you can see this fruits is a hash set that stores unique elements like apple, banana, grapes, orange. So the loop starts and pick each element from the fruits one by one. So here fruit is a temporary variable that holds the current element from the set during each loop iteration. Here I am printing one printing statement. So this printing statement prints the current element to the console. Here loop continues until all the elements in the fruits have been processed. Okay, let's run this code. Here you can see it will print this printing statement, and we are using for each loop, so it will iterate each element one by one. Here you can see in HashSet it stores unordered, which means all elements are not stored in order. In LinkedHashSet it maintains the insertion order, which means all the elements are stored in insertion order. LinkedHashSet is a class, so it is an implementation class for set interface. And one more point is it doesn't allow duplicates. It will not provide indexing as well. Let's see an example. Now I'm going to create an object for LinkedHashSet. So here I'm going to pass a type as string. So fruits equals to new, again LinkedHashSet. I'm going to add elements to the LinkedHashSet. So fruits dot add. I'm going to add apple to the LinkedHashSet. And again I'm going to add banana to the set. And again I'm going to add grapes to the set. And again I'm going to add mango to the set. Okay. So I'm printing the LinkedHashSet. So system dot out dot println. So it maintains the insertion order. So this printing statement prints the LinkedHashSet. So this printing statement prints the set. Now let's run this program. Here you can see apple, banana, grapes, mango. Yeah, LinkedHashSet maintains insertion order, so it prints the same order here. Okay. And in this example, one more method we will discuss. Method name is remove all. So this method is used to remove multiple elements at once. For that, again I'm creating an object for LinkedHashSet. I'm giving a type as string. So remove items, new. So here I'm creating LinkedHashSet. So I want to remove banana and grapes. For that, here I'm giving remove items dot add. Sorry. So adding banana to remove. Removes banana from this set. Okay. And one more item I need to remove from this set. Remove items dot add. Here I'm going to add name as grapes. Now removing specified elements from the original set. For that, fruits dot remove all. So here I'm giving remove items. Now I want to print the updated set after removal. So dot out dot sorry out dot println. So here I want to print fruits. So this line represents removing specified elements from the original set, and this line prints the updated set after the removal. Okay, let's run this program. Here you can see this is our original set. Now we are going to discuss about TreeSet. TreeSet is a class, so it is an implementation class for set interface. It stores sorted and unique elements, which in TreeSet all the elements are stored in ascending order. All the elements are unique elements. Why? Because TreeSet will not allow duplicates. Let's see an example. Now I'm going to create an object for TreeSet to store the numbers in sorted order. TreeSet, I'm importing java.util.package. So here I'm passing a type as integer. So here num equals to new TreeSet. Here I'm adding elements to the set. So num dot add. Now I'm going to add elements to the TreeSet. I'm going to add 50 here. Here I'm adding 60. Here I'm adding 70. Again I'm adding 50 here. Here I'm adding 60, 80. Let's run this code. Here you can see 50, 60, 70, 80. Here all the elements are printed in sorted order. Here it removes the duplicate elements. Here I'm giving 50 value 2 times. But here you can see 50 value it returns only 1 time. Now in this example, one more method we will discuss here. First method. First method. This method is used to get the smallest element to the set. So here I'm printing sys.out dot println. Here I'm printing the first element. So I'm using first method to print the smallest element. Okay. Now let's run this program. Here you can see 50 is the smallest element from this set. So it returns the first element as 50. If you want to get the largest number from this set, then use last method. Let's copy this line and paste here. Here I'm using last method to print the largest element from the set. Okay. Here you can see this printing statement is used to print all the elements in sorting order, and this statement is used to print the smallest element from this set, and this statement is used to print the largest element from this set. Okay. Now let's execute this program. Here you can see it prints the all elements in sorting order, and it removes the duplicates as well. Here you can see first element is used to print the smallest element from this set, and next printing statement is used to print the largest element from this set. So it prints 80. And next one is queue interface. It is the sub interface of collection interface. So it follows FIFO. FIFO means first in first out order. Here the elements added first is removed first. It means elements are processed in the order they were added. For example, just like a queue in the theater, the first person in the line is served first, right? And next one is used in scheduling, common in CPU scheduling, task management, and printer jobs. CPU scheduling. It means tasks are executed in the order they arrive. Next one is task management. It means jobs are executed one by one in sequence. And next one is printer jobs. Yes, the first document sent to the printer is first printed, right? Next here, implementing the queue interface. Common implementation, linked list, priority queue, array queue. Linked list, it implements a queue with linked nodes. Priority queue, it orders the elements based on priority. And array queue, it is faster and resizable queue using a dynamic array. Okay. And main methods in queue interface. Add method, it is used to add an element. Remove method or poll method, it is used to remove and return the first element. Peek method, it returns the first element without removing it. Let's see an example for queue interface. Now I want to create new class. Here I am giving a name as queue example. So I'm quickly create a main method. So inside this method, here I am creating a queue using linked list. So queue. Here I am giving a type as string. Queue equals to new linked list. So here I'm adding elements to the queue. So queue dot add task 6. Here I'm going to add as task 7. And again I'm going to add task 8. And again I'm going to add task 9. So now I'm printing the queue. Dot println. Okay, now let us execute the code. Here you can see task 6, task 7, task 8 and task 9. It returns the output here. So here it displays all the elements. Now I want to retrieving the first element without removing it. So I need to use peek method. Peek method is used to show the first element. Okay. So dot out println. Now I want to retrieving the front element without removing it. So I need to use peek method. Peek dot peek method. Okay. Now let's run this code. Here, here you can see. Here it displays the first element from the queue. Now I want to remove the front element. So here I need to copy this line. And now here I paste this line. So if I want to remove the front element, then I use poll method. Okay. So here I'm using poll method. So after using this poll method, this task 6 is removed, right? So now I want to print the queue after the removal of task 6. Okay. Now let us execute this code. Here you can see this is the original queue, and I want to show the first element from the queue. So I'm using peek method to show the first element, and I want to remove the last element and I want to remove the first element from this queue. So I'm using poll method to remove the first element. So here I'm printing the queue after the removal. So task 6 is removed from this queue. Okay, thank you. Guys, today we are going to discuss about map interface. Here map is an interface. It is present inside java.util package. It stores key and value pair. Here each key is unique and each key maps to the single value. Here keys should be always unique and values can be duplicated or repeated. And also both key and values is considered as an object. It does not follow ordering. Yes, ordering depends on the implementation. And here you can see map is an interface. And map interface has three implementation classes. One is HashMap and LinkedHashMap, and other one is TreeMap. Here HashMap is an implementation class for map interface, and LinkedHashMap is an implementation class for map interface, and also TreeMap is also an implementation class for map interface. Here you can see class to interface we are using implements keyword, and interface to interface we are using extends keyword. Okay. Now you can see HashMap, LinkedHashMap, and TreeMap. Okay, map is unordered and fast access, which means hash map all the elements are not stored in order, and also it provides fast access. Linked hash map, it maintains instruction order. In tree map, it stores all the elements in ascending order. And some of the key methods here you can see. Put method is used to add or update a key and value pair, and get method is used to retrieve a value from the given key. And one more method, remove method, is used to remove key value pair. Contains key method is used to check if a key is exist. Contains value method is used to check if a value is exist. And next one is key set method. It returns all keys as a set. And next one is values method. It returns all the values as a collection. Okay. Now we are going to do one example by using all these methods. Okay. Now here I am creating new class. Class name is map examples. So quickly I am creating one main method. Now here I want to create an object for hash map. So here I am passing a type as string. Now which equals to new hash map. Now I'm going to add key value pair. So h dot put method I'm using. Here put method is used to adding a key value pair. So here I'm giving a key name as. So here I'm giving a key as name and value as Rani. Okay. Now I want to print the key value pair. So system dot out dot println. So here I'm giving key as name, value as plus h dot get method I'm using. Here I'm using get method. It is used to access the value associated with a particular key. So key is present, it returns the value. If the key is not present, it returns null. So here I'm using get method, and here I'm passing a key. Now I want to remove the key. Then I use remove method. So I want to remove the key. That's why I'm giving the key name. And again I want to check if the key is present. If the key is present, it returns true, else false. So for that I'm using contains key method. So sysout dot println. So here h dot, I'm using contains key method. Here you can see it is available here. Here I'm giving a key name. So name. Let's run this code. Here you can see, here we are giving a key as name and value as Rani. Okay. Sorry. And value as Rani. Here I want to remove the key. So contains key is used to check the key is present or not. If it is present, it returns true. If key is not present, it returns false. Here we are removing the key, so it returns false. Okay. Again I'm adding another key value pair. H dot put. I'm adding key as is, comma, value as 18. So here I want to printing the A's key value pair. So system dot out dot println. So here, sorry, key colon is, comma, value colon h dot. Here I'm using get method and here passing an is. Okay, let's run this code. Here you can see one more key value is added here. And here I want to check if key is present or not. So I'm using contains key method. If key is present, it returns true. If key is not present, it returns false. Okay, I'm giving name. Here I'm giving the key name. So let's run this code. Here you can see it returns true. Here you can see, here I'm creating an object for HashMap and I'm adding key value pair by using put method, and I'm printing this method, and also I'm printing this pair using get method, and I want to remove the key. So that's why I'm using remove method, and I want to check the key is present or not. So I'm using contains key method. If key is present, it returns true. If key is not present, it returns false. Again I'm adding key value pair by using put method. So I'm printing this key value pair, and again I want to check if key is present or not. If key is present, it returns true, otherwise it returns false. Here you can see, first I'm adding the key value pair, name Rani, key as name, value as Rani, and here I'm removing the key. So it checks, contains key is used to check if key is present, it returns true. Here I'm removing the key, that's why it returns false. Again I'm printing the key as is and value as 18, and here I'm again checking key is present, it returns true, otherwise it returns false. So age is present, so it returns true. Now I want to create an object for LinkedHashMap. So here I'm giving a type as string, comma string. L equals to new LinkedHashMap. Now I'm adding key and value pair. So L dot add. So L dot put method is used to add key and value pairs. So here I'm adding name, comma value as Raj. Now I want to print the key and value pair by using get method. So system dot out dot println. So L dot, I'm using get method. So here I'm passing a key value. Now again I want to add another key value pair. So L dot put, here I need to add is, comma value 18. and again adding another key value pair, L dot put. So here key is city, value is New York. Okay. Now I'm printing the key and value pairs. Now I'm printing the A's key and value pair. So here I'm giving the name as key name as A's. Again I want to printing city key value pair. So here I change the name as city. Okay. Now I'm using two more methods. One is contains value. Yes. Contains value method. If the value is present, it returns true. Else it returns false. So here I'm using contains value method. So L dot contains value. Here I'm giving a value as 20. Sorry. Here I'm giving a value as 18. So it checks the value 18 is there, it returns true. If 18 is not there, it returns false. Okay. And one more method I'm going to use key set. This method prints all the keys. So L dot key set, which is available here. You can now let's run this code. Here you can see I'm creating an object for TreeMap, and here I'm adding key value pair, and here I'm printing the key value pair, and again I'm adding another key value pair, and again I'm printing the key value pair, and again I'm adding another key value pair and printing the key value pair. So here I'm using three methods. Before that I'm going to execute this code. Here you can see name Benny, age 2, country USA. Now I'm going to use first key method. So this method getting the first key value. So this method getting the first key. So in this statement I remove these and I'm first key. So here I'm using a method as first key. Yes. And next method I'm using values. So this values method printing all the values. Now copy here values. Sir, here I'm using values method, sorry. Now here you can see first key method is used to print the first key, and values method is used to printing the all values. Okay, let us execute the code. Here you can see it print all the key and value pairs, and key here the first key is name, right, but it displays the first key as is, but because in TreeMap all the keys are stored in sorted order, so based on the alphabetical order it displays the key value. Okay, and next it prints the all the values. So values method is used to print all the values. So here you can see it print all the values. Okay, thank you.